In our third example, we are trying to prove that angle 2 or angle 3 is equal to angle 4. The tricky part about this is we don't get any information inside that triangle at all. We are given that angle 1 is equal to angle 2. Those are down here. We are also told that AC is equal to BD. Now you'll notice none of these things are marked on our picture, so let's go ahead and mark them all on our picture right now. So we got 1 equal to 2, AC equal to BD. What I see as an opportunity here is I do see vertical angles, and when we have that, we can prove using angle, angle, side, and angle, angle, side that these two triangles on the ends are congruent. So I see that by angle, angle, side, and vertical angles, I get these two being congruent to one another. The question is that useful? We want to prove something about 3 and 4. How does that help? Well, if we prove that these two triangles are congruent, we also have proven that all the corresponding parts of the congruent triangles are congruent, including these sides right here. And if those two sides happen to be equal to one another, we've shown that this is an isosceles triangle. And an isosceles triangle, when you have two equal sides, also is going to have two equal angles at the base, which means that 3 and 4 would have to be equal. So that's going to be our roadmap or our game plan to solve this problem here. So let's kind of work our way back and see how we did that. We got the vertical angles, we had the angle angle side to get the congruent triangles, we had the CP/CTC to break it apart, and then we use the isosceles triangle theorem. So let's write that out more formally. We have our given always in our first step. In our given, we write out everything we're given. So angle 1 equals angle 2, AC equals BD. So that's everything we're given. Next thing, we want to get those angles in the middle here. We did that by vertical angles. So by vertical angles, we get that the angle E's are equal. So let's give it a three-letter name. AEC, angle AEC is equal to angle BED. So we have our vertical angles giving us that. Now we've proven that the triangles are congruent by AAS, angle angle side. So let's write out our congruency statement. We have the single marked angle here, angle 1, which would be A. We have our middle angle, E, and then we have our bottom angle unmarked, C. And let's make sure that matches up now. We have our congruent angle starting with B. We have our middle angle that's equal here by vertical, E, and then we have our unmarked one, D. And you'll notice here it actually turns out that these two steps have similar orders of letters. That will often happen with triangles when you have a three-letter angle name and you have triangles with only 3 points. That's a pretty common thing to happen. Not always. Finally, we're going to break apart this triangle. We have a couple more steps. We're going to use that CP/CTC we were talking about earlier, and we're going to break apart this triangle and get all of the corresponding parts. In our case, we only need one particular one. We have this AE and the BE that we care about. So the first two letters and the first two letters are the ones we're going to break apart. So AE equals BE. And once we have that, we know we have an isosceles triangle, so we get the angles. We have the sides being congruent. Now we need to get the angles being congruent. So by isosceles triangle theorem, we get the fact that angle 3 and angle 4 are equal. And that is exactly what we are trying to prove. So we are done.